Okay, back to the 2003 AB exam. We're doing the calculator questions. 76 it starts out with. Going to 76, the first of the calculator multiple choice. All right, so they give you the velocity and they ask you what's the acceleration when t equals 4. What do? You got your calculator. Plug it into what? So you want to put v of t in y1? All right, that's not really going to help you. We don't have to graph anything. What does the acceleration have to do with the velocity? It's derivative. So you got to know what the derivative of the velocity is, and what are you plugging into it? 4. Calculator does that. The calculator gets the derivative and plugs in the number for you. So the question is, how do you do it? So we go to our calculator, and what do I put in? Okay, n deriv, math 8. We put in the function. We don't have to take the derivative of anything ourselves. If we have a calculator to do it, 4.1. Make sure you are in radian mode when you do this test. And you will fail. Comma x, comma 4. So you put in the function, comma x, comma where you wish it, give you the derivative. Okay, get that right? You did the derivative without the calculator and plugged it in? Okay, just realize, it probably didn't take you too long, but that's one of the things you can do with the calculator. You don't have to waste time. So the answer is C. $77 for C. Okay. 77, they tell you that this area is 2, this area here, B is 2, and this area C is 2. And they want to know what the definite integral of f of x plus 1 is. This is a common question where they want to know that you know that you can break up a sum or a difference. Okay, so the first thing we can do is we can break it up to the definite integral from -3 to 3 of f of x, which we're going to get that from the graph, because we know the connection between definite integrals and area. Definite integral is area above minus area below, plus the definite integral from -3 to 3 of 1 with respect to x. And that we're going to get from knowing how to integrate using the formulas. So this idea of making us find a definite integral by breaking it up and getting part from the graph and part from actually integrating has come up. I've seen in several of them. Okay, so let's do the graphic part. We want the definite integral from -3 to 3. Remember, it's area above minus area below. So what is the definite integral from? It is -2, okay? Because you have 2 above and you're subtracting the 4 below, you get -2. For the second part of this, we actually have to take the antiderivative of 1, which would be x, and we're evaluating it from -3 to 3, meaning that we need to plug in the 3, plug in the -3, and subtract. So 3 minus -3. Good. So we have plus 6, and -2 plus 6 gives us 4. Another choice C. No calculator needed for that, but it was there anyway. Questions? 78. A lot of words. The radius of a circle is increasing at a constant rate of 0.2 meters per second. Can you translate that to me into symbols? What is that saying? The radius of a circle is increasing. dr dt equals 0.2 meters per second. Good. What is the rate of increase in the area of the circle? So what are they asking me for? What is dA dt at the instant when the circumference is 20 pi meters? So when the circumference equals 20 pi. So they gave me dr dt. They're asking me for d a dt. What do I need a formula for? The area of a circle in terms of the radius, right? So what is the area of a circle? Pi r squared. So when we take the derivative of both sides, we'll have a dA dt on one side, a dr dt on the other, and hopefully we can figure it out. Okay, so we've got dA dt equals, and what would be the derivative of the other side? 2 pi r dr dt. And we want to figure out what dA dt is. I know for the dr dt, I'm going to put in 0.2. What do I put in for 2 pi r? 20 pi. They told us what 2 pi r was, because that's what the circumference is. So 2 pi r equals 20 pi. And what's nice is I don't have to first figure out what r is and then plug it into this. I can just plug the whole thing in, because that is the circumference. And we're going to leave our answer in terms of pi because they did. So we need to multiply 20 by 0.2. So 1/5 of 20 is 4 pi meters per second. Is that another C?
Yeah.
That is another C. So the answer is always C. Circumference of a circle, you have to know, is 2 pi r. Okay? You got to be clear on that. The area, what's that? Yeah, just put in C for everything. It's a lot easier just to put C than to try to memorize all this. All right. 79, just get this out of the way. It says, for which does the limit of f of x as x approaches 4 exist? The limit existing. Remember, the limit is just the y that it's approaching. So for a limit to exist, the left and right hand limits have to be the same. In other words, it has to be approaching the same y from both sides. Doesn't have to get there. So what do you think about number 1? Does the limit exist? Yes. It's approaching the same y value. Now, what you might have been confused about is the difference between that and being continuous. To be continuous, the y that it gets to has to be the same. That would have had to be filled in. Just said for the limit to exist. So this is continuous. How about number 2? Yes, the limit also exists. Again, it's not continuous, but the limit exists. It's approaching the same y from both sides. And what about 3? No. The left-hand limit, the y it's approaching from the left, is different than the y it's approaching from the right. So we want to say 1 and 2. So that is choice D. You enjoying this? This is good? I love this. Now, 80 is one of those questions that probably a lot of people pass on, but I want you to recognize the setup. This is the beginning to one of the few theorems you have to know for this class. A function is continuous on the closed interval from -2 to 1, and it's differentiable on the open interval. Does anyone know what theorem that's the beginning of? The mean value theorem, right? Mean value theorem, you hear that. I mean, I haven't finished reading the question. I'm expecting that. All right, if they just say it's continuous, I'm expecting an intermediate value theorem or extreme value theorem saying it has a max or min. But I'm all set for that. But let's check what they say. They also give us the 2 points. They tell us that f of -2 is -5. And f of 1 is 4. So I might as well write that down. -2, -5, 1, 4. Which of the following could be false? There has to, for A, it says there exists a C between -2 and 1, such as f of C equals 0. Does the y coordinate, if this function is continuous and differentiable, does it have to go through 0 somewhere between -2 and 1? Yeah, there's no way. And that's the intermediate value theorem. If your function's continuous, you have to go through every y from the one endpoint to the other to get to the other. and 0 is in between there. So that is definitely true because of the intermediate value theorem. So A is true. B, there's got to be a C between here where the derivative is 0. Does the derivative have to be 0 to get from this point to this point with a smooth curve? No. Give me an example. What could it look like? It could be a straight line, and the derivative would never be 0. So B does not, it could be false. So that's the one. It could be true, but the thing is they said could be right there. Somewhere in here they are going to have, it's probably choice D, the mean value theorem. If you figured out the slope between these 2 points, you'd get 3. So the derivative does have to equal 3 somewhere between. And what about C? How do I know C has to be true? Why do I know that the y coordinate's got to equal 3 somewhere between these 2 endpoints? Yeah, it goes up to 4. You can't get to 4 without going through 3, right? That's the intermediate value theorem again. And E, that's the other theorem for continuous functions. It's saying there's got to be a greatest y value. There has to be a max or min. And when you have a continuous function on a closed interval, some y value has to be greater than or equal to all the other y's. So that's what that's saying, and that has to be true too. So choice B was the one that could be false. 81. They give us the derivative, and they want to know how many relative extrema does it have between 2 and 4. I have my graphing calculator. What am I looking for? When it crosses the x-axis. Good. Has to change sign. So I'm going to graph this derivative between 2 and 4, and I'm going to look to see how many times it crosses the x-axis. You're spacey? You seem good. Oh, thanks. Save me. I have too many pluses. Never be too positive, except on the calculator. Okay. So when I do my window, when I set my window, it's going to be from 2 to 4. They tell me the x's. Do you guys remember how you fix the y's once you set the x's? How do you set the y's? Well, you actually, all you care about where it crosses, you could go from negative, but zoom fit will take you right to a beautiful window. Once you fix the x's, if you say zoom 0, it'll give you a beautiful window. We only want to see it from 2 to 4. And so how clear is this? So how many relative extrema will we have if this is the derivative? 4. No infinity, right? It changes sign 4 times from negative to... And by the way, this first relative extrema, would it be a max or a min? A min, because it's going negative to positive. This one is positive to negative, so max, min, max. They didn't ask us how many min, how many max. Oh, right. So let's go back. I set the x's 2 to 4 because they told me that. And then I just hit zoom fit because that'll make the y's pretty. It doesn't mess with your x's, though, which is important. Oh, so the answer was D. I didn't write down. Okay, 82. They give you a function, the rate of change of the altitude is given by r of t equals t cubed minus 4t squared plus 6 for t between 0 and 8. They give us the units for that? I was kind of, no, they did not. Okay, anyway. But that's the rate at which the altitude is changing, which gives the change in altitude during the time the altitude is decreasing. Oops. Okay, did you integrate this from 0 to 8? Because that would give you the total change in the altitude, but what's wrong with doing that? You have to first find out when r is decreasing, okay? Because you only want to integrate it when it's decreasing. But we will be integrating the rate at which the altitude's changing. But let's see when the altitude's decreasing. How am I going to find that out? You're going to graph the rate at which it's it's the altitude's changing. We're looking to see where it's negative. So this is already the rate of change. Yes. See where it's negative. Not where that's wait a minute. The change during the time the altitude is decreasing when its rate of change is negative. So we want to graph R of t because this is a derivative, even though like they didn't call it something prime. Yeah. It is a rate. So we're going to graph this derivative. It's really, it would have been nice if they had called this dA dt for the rate at which the altitude is changing. It would have been more obvious. But they will do that a lot. Okay, they will not identify a derivative with a prime. So let's see when this is negative, and then we'll know when to integrate this rate. So we go to our calculator. X cubed minus 4x squared plus 6. Now I'm going to set my original window 0 to 8, and then we'll, because, really? Well, as long as I put my 0 to 8, then I'm just going to hit zoom fit. Zoom fit. Wow, that's not such a great window to see where it's negative, right? So I'm going to actually change it myself. I don't have to see all the way up here. I want to change those Y's. So I'll go to my window. I don't have to go so high. This wasn't bad. This whole -4, I'm sure was low enough, but it was this one. I don't need to see all that. Maybe I'll just make it 4. I don't even need that high. You don't. That's kind of wasteful. Okay, but okay, so we need to find out what this interval is. We are trying to find out the interval when R is negative. So let's get those zeros, and I'm going to store them in A and B. I want to find out what these two values are. So second, oops, close link, we don't need it. Second calc, option 2. Left bound, get my first one, where am I? Go to the left of the 0 and hit enter. Right bound, enter. And I have it 1.57. I'm going to leave this and hit store alpha A. Enter. Make sure you do enter for that. Go back to our graph. Second calc, option 2. Left bound, to the left of it. Oh, I just have to remember what it is. Okay. All right. That is a good point. I don't. And guess. Okay. So this one was 3.514. So since we don't actually have to get the change, there is no sense in me storing this in B like I normally would. So that was 3.514. So we're all set to set up our integral. So we know we have to integrate the rate at which altitude is changing, which is just our R of t. And my limits of integration, 1.572 to 3.514. We got to be careful because a lot of them, they kind of look alike. Which one says that exactly? It's A, because you see the problem with D? Yeah. They put that prime on there because, again, they're trying to make us think that that wasn't already a rate. This is true. A. You guys got as far as 83, right? Yeah. About, this is like where some people kind of... All right, let's try this 83, and then I'll give you another couple of minutes to get yourself ahead. It was A, yep. It was A. 83, the velocity in feet per second of a particle moving along the x-axis is given by v of t equals e to the t plus t e to the t. What is the average velocity? I gave you velocity, they're asking for the average velocity from t equals 0 to t equals 3. What do we do if we want the average value? Okay, the average velocity is a tricky one, guys, because there's two ways to get it. Your average velocity. If you're given the velocity, you want the average. I don't care what the function is. You've got the function. You want its average. Which formula do you use? The average value of a function. the average value one. So one way to get the average value is to take the definite integral of the velocity from your a to b over b minus a. So this is what you need to do for here because you're given the velocity. What you guys are confused with is the other way to get the average velocity, because average velocity is another way of saying the average rate of change of position. Okay, it is the average rate of change of position, and since it's the rate of change of position, it would be S of B minus S of, oops, I'm going to write S for position, A over B minus A. So there's two ways to get the, depending upon what you have. If they gave me the position function and I wanted the average rate of change of position, the average velocity, I would use difference in position over difference in time. But here we're going to use this one, and so we're going to integrate 0 to 3. So we're going to go right to our calculator. You love this? Is that what you're saying? You love this? Ellie just said he loves this. He loves this. Good. That's just for the record. Let that be noted. He's loving this. So we do math 9. I'm so glad that problem came up. The x plus x e to the x. Try to get that in right. Comma x, comma 0, comma 3. Oh, and I need to, you're right, that's just a definite integral. I still have to divide this by 3 minus 0. I'm surprised I didn't leave the 60 there as a choice for the poor kids who forgot to divide. That would have been a nice little trap. Okay, so we have choice A. Average value, it's either what you have, use the mean value theorem for the integrals, or average rate of change, it's the other one. Average acceleration, you could either do change of v over change of t, v of b minus v of a over t minus a, or if you have the acceleration formula, take the antiderivative of the acceleration over b minus a. Well, no, either, like, you're right when you say yes. Yeah, if you're asked for average velocity, there are two ways, but you're right. If average acceleration, there would also be two ways. If you have acceleration, you got a formula, take the definite integral of it over b minus a. If you have velocity, do the v of b minus v of a over b minus a. And like, I know that seems like I'm saying two different things, but think about it. Let's see why these are the same. If I asked you to take the definite integral, what's the first thing you have to do? Antiderivative. What is the antiderivative of velocity? It's the position. And then it would be the position, and you would plug in the b, right? And you'd plug in the a. So it is the same thing, okay? Do you see that? That the average velocity, you could either write it from the left here or on the right. It's the same thing. If I were to follow this through. It's just that I have the calculator, so I'm using this one. Okay. Yeah, it depends what you have, but realize they're both equal the average value, the average velocity. Oh, did I ever answer that? So that was choice A. You want lollipops. They want a lollipop break. Let's see what lollipops we have left. 20.086. Okay, I'm going to pause this while I let you guys have another few minutes. We are back. Okay. A lot of words. That's what it says. 84. A pizza heated to a temperature of 350 degrees Fahrenheit is taken out of the oven and placed in a 75-degree room at time t equals 0 minutes. Okay, so it's starting out at 350 degrees. The temperature is changing at the rate of this little formula there, negative 110 e to the negative 0.4 t, degrees Fahrenheit per minute. To the nearest degree, what is the temperature of the pizza when t equals 5 minutes? Okay, we have the rate at which the temperature is changing. If we integrate that, what's that going to give us? The total change in the temperature, right? Now, they actually want to know what the temperature is. They don't say what is just the change. So whenever they want to know what the value of a function is, you got to take what it started with, starting value, right? And then you can just subtract or add this change, which where this rate is negative, so it will be a negative number. Okay? So the idea is to get the temperature at 5 minutes. We're going to take the initial temperature of 350 and add to it the change from T is 0 to T is 5 of this negative 1, 10 e to the negative 0.4 T. All right, we'll go to our calculator. And if it's more than 350, see, it says changing at a rate of, so they put the negative in there. Sometimes when they give you a rate, they say it's decreasing at a rate of, and if you don't put the negative in there, it'll throw off your answer, so you have to make sure. All right, so anyway. Home screen. There. So I want to take 350 plus math 9, negative 1, 10, second e to the negative 0.4 x, comma x, comma 0, comma 5. Okay, so there we go. We just put it all in the calculator after we set it up, and we got an answer of 112.21 degrees, nearest degree 112. When you're given a derivative, you use math 9 to get the total change. And the question is, do they just want the total change, or they want a functional value, in which case you got to add the change to the starting value. Yeah, it does come in very handy. Okay, so we got 112 degrees, which is choice A. Ilya got that one wrong. I'm sorry. What was that? What, what was it? Oh, you want to see the, yeah, it's going to say on the video forever. What do you want, the calculator? So we took the starting value. All right with that? Yeah? Sure? All right. No. Everyone else got it right? Good, good. Okay. All right, 85. Now, in this one, they say, okay, you got a function where if you use trapezoids, it's going to give you an over approximation. So if trapezoids give you an over approximation, what do you know about the function? With trapezoids, under or over is determined with concavity. Okay, if trapezoids give you an over approximation, it means the function's got to be concave up, right, for the trapezoid tops to be above. So from that, we get concave up. And right rectangles, the right rectangle approximation gives you an under approximation. So if using the right side gives you an under approximation, what do you know about the function? Decreasing or increasing for the right? Oh, yeah. Wait, for the right, yes, it would be. I had it in my head the wrong way. Yes. Yes. If it's decreasing, the right side will be lower, so that'll give you an under approximation. So from the second clue, we know that the function's got to be decreasing. So yeah, you look for the choice that's concave up and decreasing, and there you go. The answer is not B, it's A. Okay, that's the thing with those approximations. Trapezoid, it depends upon the concavity, and rectangles, it depends upon the increasing, decreasing.
Is it the same for the left and right?
Yeah, I mean, oh no, it's the opposite. Like, you know, you have to like think of the picture. If a function is decreasing, the left will be over.
Right, some we go over, we go up, and
well, if you're using rectangles, if you've got a function that's increasing, okay, if the function's increasing, I don't even care about the concavity, the left will give you under and the right will give you over. You see that? If you use the left side for the tops of the rectangles, that'll be too little. But if you use the right side, that would be over.
yes, I'm going to go to the left.
So, but if you have a function that's decreasing, it's going to be the exact opposite. Okay, now left will give you over and right will give you under. Okay, got it? All right, so the next question, 86, it's the volume with known cross sections. They give you a region, it's bound by the y-axis, the graph of the arctan of x, the horizontal line y equals 3, and the vertical line x equals 1. So you have your region here, and they tell you that every slice perpendicular to the x-axis is a square. So you have to, when you see that every slice is a certain shape, and they ask you for the volume, how are we going to get volume? You got to know the formula to get volume equals the integral of what again? Area times the thickness, and in this case, is it dx or dy? Dx. Then you got to say to yourself, well, what is the area formula for this particular shape? And this shape is a square, so how do you get the area of a square? S squared. It's always going to be in terms of some length, and the length is what you see there, okay? The side of your square is this length here. Okay, it's length. So you need to represent, oh, I guess we could do our limits of integration. What are the limits of integration? 0 to 1, because the x's of our region go from 0 to 1. And then the only other thing we have to do is replace the the length of the side, with what it equals in terms of x. Now it's a vertical distance. When you have your little formula and there's going to be a length in it, it's either going to be vertical, y top minus y bottom, or horizontal, x right minus x left. So s is 3 minus the arctan of x. That's it. And at this point, we can go to the calculator to put that in there. So what was I doing again? Oh yeah, math 9. We need a parenthesis because we're going to be squaring 3 minus. I gotta make sure I square it, comma x, comma 0, comma 1. So make sure you square that 3 minus arctan. And we get 6.612. Choice B. '87. Nice. All right. 87, they give you the first derivative, and they want the x-coordinate and the point of inflection. To find the x-coordinate point of inflection from the first derivative, we either get the maximum of this, but I've been told that when you graph this, it's hard to see the maximums. So the other way would be to find out when the second derivative changes sign. So we're actually going to have the calculator graph the second derivative. We're not going to figure it out ourselves. Yeah, nice. Bye, Rebecca. Nice.
Bye, Rebecca.
All right, bye. So to have the calculator graph a derivative without having to figure it out yourself, you put in what you want it to take the derivative of, comma x, comma x. These kids, they're all just leaving me, but it's all right. We go on. We ignore them. Bye, you're welcome. You can go on the e-board if I don't screw it up to see the rest. Divided by 1 plus x plus x cubed, comma x, comma x. Oh, I forgot the end deriv, which is the craziest thing of all. I need to do that. Second insert, math 8. Okay. So to graph the derivative of a function, which would be the second derivative, and I want to see where the second derivative changes sign to get a point of inflection. When I do this, now I'm looking at the choices, and I see the x coordinates of my choices, or between, if I set my window from, let's say, -1 to 2. I would cover all their choices to see if it's going to cross, it has to happen there. So I'm going to set my window -1 to 2. And I only care about seeing where it changes sign. So -4 to 4 is fine. I could even make that from -1 to 1 if it's not good enough. But we'll try that. So this is the second derivative, and we want to see where it changes sign, which would be right here. So we just got to find that value. So we'll find the root of this. Second, oops, close this. Second calc, option 2. Left bound, it's positive. And when I do right bound, I have to go until y changes sign, or I will get an error. And we get the second derivative changes sign at 0.473. 0.473. So we graph the second derivative by using n deriv, the first derivative, comma, x, and found out where it changed signs. You do. Ellie's all hyped up. We're at 107. What number are you? Oh, you're behind. We are at 88. 88. All right. Now, I want to see if anybody in here recognizes what this is up here. What is this saying? I'm sorry, he beat you to it. The average value. This is saying that the average value of this function is 1. So they're saying which one of these has an average y value of 1. Do you recognize it, guys? They just put the 1 over b minus a out front. All right. So let's see if we can eliminate any of these off right off the bat. Are there any of these that we can just get rid of? We know its average y value would not be 1. E is, right? Because what would the average value of an E be? Well, the average y value would be 2, because it's always 2, right? So this is not good.
You can cross out b and c because it's not differentiable there, right?
Nope. No.
Because if you take the derivative, you have to take the derivative first. I can't take the derivative.
The antiderivative.
That would be like an absolute.
Well, the derivative of this b would not exist, but not the antiderivative.
You must have the derivative. It's not antiderivative.
No, the derivative of this. He's making me look crazy. All right, what about d? What's the average value of d from 2 to 4? What would be the average y value? The y's go from 1 to 3. It's linear. It's going to be right in the middle. So the average y value would be 2, right? Because the y's go from 1 up to 3, and it's in a straight line. So the average y value would be right in the middle. That would be 2 also, that average. So that's not 1. I didn't label this one enough. Let me just see what C is. So C, the y's, this is 2 and this is 4. Okay. What would the average y value in C be?
Average value, you mean?
Average y value. Now, look at the y values here in C. You know, when you have lines, the y's are right in the middle. The average y value is right in the middle. So do you see that, what would the average y value for this between 2 and 3 be?
1.
It'd be 1, right? And then for the second part of it, also 1. So the average y value for this would be 1. This is good. But it's really important that I show you why A and B don't work. The average y value will be the middle of the y values as long as it's a straight line. But when you have different concavity, as you do in let's say A, the average y value of the function is not going to be the same as the middle, which would be the y value on this. It's going to actually, when it's concave down, the average y value is going to be above that middle value. So here, the average y value is going to be greater than 1 because it's concave down. All right, if it was linear, it'd be the middle. But concave down, it'll be above. And what about this in B? What would you,
Okay.
it's concave up, so that average y value is going to be less than the middle value, which would have been 1. Okay, so choice C. One and down, choose C. 89. They give us the value, they give us the y coordinate at a particular x value. They give us the derivative there. Oh, they don't want us to write the equation of the tangent to f. They want us to write it to g. So we got a little more work to do. Okay? But g equals x times f of x. All right. So we want to write the equation of a tangent line, which is always y minus y1 is equal to the slope times x minus x1. If it's a tangent line to g, they told us that x is 2, so we know that. But how am I going to find y1? What am I going to have to do to get y1 if it's a tangent line to g? You're going to plug it into what, though, to get to g of x? So for y1, you're going to have to get g of 2. And what are we going to have to do to get the slope of our tangent line to g at 2? The derivative of g at 2. So we got to get g of 2. Let's do that first. To get g of 2, we follow, that's going to be 2 times f of 2. 2 times 3, because they gave us f of 2. It's up here, which equals 6. The slope of our tangent line will be g prime of 2. Before I can get g prime of 2, I need to get what g prime of x equals. What am I going to have to do to get g prime of x? Product rule. Don't you dare multiply their derivatives separately. So you did that. That is the worst thing you could ever do. First times derivative of the second plus second times derivative of the first. Now we can get what g prime of 2 is, because it's going to be 2 times f prime of 2, which they did give us, negative 5, plus f of 2, which is 3, times 1. So g prime of 2 will equal negative 10 plus 3, which is negative 7. So now we can write the equation of our tangent. So it's y minus g of 2, which was 6, equals g prime of 2, which is negative 7, times x minus 2. That is choice D, I believe. D. Slow down. No, yeah, Billy's just eating a lot of sugar. That it was mine. Oh, these lollipops are being confiscated. Someone has to stop them. Okay, 90. They tell us you got this function on the closed interval from 2 to 5 where the first derivative is positive and the second derivative is negative. First derivative is positive. What can you tell me about the function? First derivative is positive. It's increasing. So f is increasing. That we know just from this. So can we get rid of any of these choices if f has to be increasing? C's gone because see how the y's are decreasing? Oh my gosh. That's crazy. And the second derivative is negative. So what does that mean about the function? It's concave down, which means the slopes are decreasing, that the changes in y over changes of x are decreasing. So that means the f is concave down, which means the first derivative is decreasing. So like your changes of y over your changes of x is decreasing. So you're looking for one where the change in, like it's increasing, but it's going up by less and less. right? If it's concave down, it's going up, but by less and less. So which one does that? Look at the y's in A. They go up by 2, then by 3, and then by 4. Those changes are increasing, right? So that's going to cause the graph to go like, woo, like that. But here in B, your slopes are increasing 4, 3, 2. So it's increasing by less and less, and that's going to give you concave down, which is what we're looking for. Ah, I know, it's exhausting. Yeah, you're getting into this. I love that. 91, they give you the acceleration. Time, of course, has to be positive in motion problems, never give a negative time. The velocity when time is 1 equals 2, and they want to know what the velocity of 2 is when time is 2. Oh, Hera's leaving us. Even though I don't want her to leave, she's still leaving. She's laughing. Okay. Now, if this was without a calculator, what would you do? You take the antiderivative, you would figure out what C is with the given point, and then you plug it in. But you have a calculator, so you don't do that when they give you a derivative and a point, when they want the y somewhere else. If I want to know what v of 2 equals, what do I start with? This is the old plus the change. You take the old value and add the change. When you're given the ingredients that you're looking for, this is the same recipe always. You're given the derivative. This is a calculated question. You're given the derivative and a point on the function. And you want the y coordinates somewhere else. That's when you use this. Okay? When you're given the derivative of a function, 1 point on the function, and you want to know the y coordinates somewhere else, you take the old y, in this case the old velocity, and I'm going to write it out. You'll take v of what v of 1 is, and you'll add to it the change. Right? If you know what v of 1 is and you add to it the change, and how do you get the change? If I want to get the change in velocity, I take the antiderivative of v prime, which is the acceleration. Okay, this is just v prime, the acceleration. So I'm just taking the antiderivative of the derivative to get the total change from the old time to the new time. So what would my limits of integration be? From 1 to 2. So it's going to be 2 plus, well, I already have this. The definite integral, if I just integrate acceleration, it's going to give me the change in velocity, but I got to add it to how much I started with, what the velocity was to begin with. Okay, and we'll go to the calculator, of course, for this. So we're going to take 2 plus sine of ln of 1 plus 2 to the t. Home screen, clear it. 2 plus math 9. Thank you. ln parentheses plus 2 to the x. Yeah. Okay. What did I put too many parentheses in there? I did. Let me just get rid of that one. Delete that. Okay. And I want it, comma, x, comma, the old to the new. So it's comma 1, comma 2. All right, and I already in front did the 2 plus. So I have velocity was plus the change of velocity, which I get by integrating its derivative. All right, let's see what it says. Is that what you got? All right, well, you got one right, just for the record. You got one right. Very, very good. This comes up a lot. Calculated questions, you know you're going to have to do this. So this is 3.346. Choice A. 92, the last calculator question. Now, they give you a g of x's, it's one of these accumulation functions, and they want to know where is g decreasing. You got to make the connections right away to derivatives. If g is decreasing, what are we looking for? G prime is negative. Nice. So we got to find out, first of all, what g prime is. So you got to know how to take the derivative of one of these things. And then we'll find out where it's negative, where g prime is negative. Okay. So you know you're going to have to be able to find the derivative of one of these. And this one's easy because it's just 0 to x. But in general, to find the derivative, it's derivative of upper, plug the upper into t, minus derivative of lower, plug the lower in. But this is just from 0 to x. So what do I get for g prime? Sine of x squared. So let's see where it's negative. And that'll be our answer. We've got a calculator. And if you notice this interval here, when I do my x min and my x max, that's where I'm going to set it, what they gave me. So x squared. And we're setting our window from -1 to 3. So I do window, oh, it's right at -1 to 3. And I only care where it's negative, so this -4 to 4 is probably fine. Now, yeah, you know, and I don't even really have to, I knew my x scale was 1, so I know these marks occur every 1. So even just looking at these choices, I think it's going to be D also, because that's 1.772 to 2.5. Yeah, because you're looking to see where is this negative. It's negative when the graph's below the x-axis, so you're looking from this x to this x. And I would just look at that and just pick D. But we'll find the actual answer. We'll find what these roots are, because it's between these two numbers. So the second closest, second calc, option 2. Left bound, good. Right bound must be of a different sign. There it is. There's the 1.772. All right. We go back. We do it again. Second trace. Option 2. Left bound. Right bound. And there it is. So we know it's negative between the 1.772 and 2.507. And let's go back. What is that? 0.7? Is that when they ask you questions about yourself? Yeah, they'll ask you this question. No points. Yeah, they're not going to take off points for that. All right, so that was the end of the graphing calculator part. Multiple choice. Okay, we're back, and kids here chose question 5 to do. If you look at the other questions, you got your basic area volume. You have your motion problem, your tables, graphs, your rate problem, and this one here is 5. Okay, so here they give you a cylinder. It's got a radius of 5 inches. The height of the liquid in there is h. They tell you the volume is changing at the rate of -5 pi square root of h cubic inches per second. So that is dV dt. So they gave you dV dt. They gave you what the volume of a cylinder is, and this liquid is in the shape of a cylinder, so that's helpful. And they want us to find the HDT. And not only do they want us to find this, they told us what the answer is, just so we know we got the right answer. They said, show that the HDT is square root of h over 5. So we have dV dt, we want the HDT, and hopefully it'll turn out to be this. All right, so we're starting out, the volume, you have to remember with cylinders, the radius does not change. So whatever that number is, you need to put it in first. Cones, the radius changes, so you can't put a number in there. All right, use similar triangles to come up with what it is in terms of the other variable. But volume in the cylinder, it's pi times 5 squared h. So wait, say that again. When you take the derivative.
When you guys take the derivative back, and you get dV, you took the derivative.
No, we haven't taken derivative. We're saying the volume of liquid in this cylinder is equal to 25 pi times the height. We're just saying what the volume is here, because the volume of a cylinder, the radius doesn't change. Okay, so you don't put a variable in. In the formula, it's it's an r.
What's the f squared?
That's squared. No, that's a 5.
Oh.
Okay.
That's good.
So the volume of liquid in here is 25 pi h. You have the VDT, you want the HDT. This is a nice, easy question now. If you have the VDT and you want the HDT, what should you do to both sides? Take the derivative with respect to time. So we have d VDT equals 25 pi HDT. Now they gave us dVdt, right? dVdt they gave us was negative 5 pi square root of h. So that has to equal 25 pi h dt. We just divide by 25 pi. And that cancels. And the pi's cancel. I might as well use the same color. And so we wind up with negative square root of h over 5. Just like they promised it would be. Those show that questions are awesome because you know what the answer is. You just showed how to get there, okay? But that was a tiny related rates thrown in, and the rest of the problem is going to be differential equations where you're given the derivative and you got to separate and integrate, which is a more basic type. So in part B, they got to give us a point so we can figure out what C is. They say h is 17 at time t equals 0. So I'm going to write h of 0 equals 17. Solve the differential equation. dh dt equals at negative square root of h over 5 for h as a function of t. Solve a differential equation, you separate and integrate. So let's get the h's on the left and the t's on the right. I'm going to leave the negative over there on the right. So dh over the square root of h equals negative 1/5 dt. I divided both sides. That is? It's so different when you said it. So you separate the variables by multiplying or dividing. In this case, I divided both sides by square root of h, and I multiplied each side by dt. And then you integrate. And the plus c you save for the independent variable side, the t side, the x side. Now we're integrating h to the negative a half. All right, we're integrating, if I write it as a power, you can always write it up as a power unless it's to the negative 1. You don't want to use the power rule. So if you take the antiderivative of h to the negative a half, you add 1 to the exponent, multiply by its reciprocal, what do you get? 2h to the half. So I'm going to write 2 square root of h. On the other side, we're integrating with respect to time, dt, so what do we get? Negative 1 over 5t plus c. I think before I do anything else, I would divide through by the 2. Okay, so we will have the square root of h. Well, we wouldn't take the square root, we would square, right? But if I divide through by 2, what is the coefficient of t going to be now? Because you're dividing by 2, negative a fifth over 2 should be a tenth. And you leave it the plus c, because now it's a different t. Until you find it, you can keep calling it plus c. And now we're going to use our point. Yep. So t is 0, h is 17. I guess I can leave it like this. That's crazy if you got that number. Okay, so we have c as the square root of 17. So we go back and whatever point we decide to plug in numbers, that's where we go back and put the c. So we have the square root of h is equal to negative 1/10 t plus the square root of 17 just square both sides. So that h is just all this squared.
That's it.
Yep. Okay, solving a differential equation should be, it'd be very weird if it was not a free response, no calculator question. That's one of the big topics. So you have a formula now for the height of this coffee in there as a function of time. In other words, you give me the time and I'll tell you the height of the coffee. But in part C, it says at what time is the coffee pot empty? So what are we going to have to do to find out at what time is the coffee pot empty? H is 0. So we put in 0 for H, and we just have to solve this. Now this is no calculator question. You can square root 0. Square root of 0 is 0. So we do have, and that would be the first thing to do is get rid of that squared, because it'd be plus or minus the square root of 0, but it's still 0, right? 0 equals negative 1/10 t plus the square root of 17. You minus the square root of 17 equals negative. And then you want to get t by itself. You could divide by negative 1/10 or multiply by negative 10. So, all right. And that was it. Wasn't that nice? So it looks intimidating, but it was kind of neat in this problem because they did put a tiny bit of related rates. I told you that wasn't a huge part of the free response. That has been a free response question. Like, remember the coffee pot problem? There was another time, but very rare, very rare. It's mostly differential equations.